far away, no use at all. Unnecessarily, we are learning these things. Those memes are for those who don't understand anything at all. But in fact, you are also using complex numbers very much. You just don't know it. That's why you should know properly why you are studying something, what are the uses. Like Pythagoras theorem, you have just seen that in triangle, and that finding circumference, you need to use that 2 pi r formula, where pi is an irrational number. So these numbers are quite useful. It is not only about money transactions, which we can perform with the help of rational numbers. Other things are also useful. The most important thing to know is that complex numbers are not used like this in our everyday life. Because our everyday life consists of a very small portion of computation. Most of the computations are at the higher level. So in scientific computations, mainly complex numbers are used. In your mobiles, laptops, many apps you are using, so there are the uses of complex numbers. Everything like image processing, editing an image, all those things you use Fourier series, Fourier transforms, where complex numbers are used, and in many of your experiments you will be using. It's not that completely useless. So directly in real life, we may not find a use of complex numbers, but you need to remember that complex numbers are used for advanced computation. So let us see what is the definition. Definitions are well known to you. Complex numbers Z can be defined as ordered pairs Z equal to xy of real numbers. We can write a complex number in this form: Z equal to the x is the real part, y is called the imaginary part. Instead of writing like this, usually we write x plus iy form. But that I remains constant. I represents the imaginary unit, so it does not change. So instead of writing I always, we can write in this form also, just that real part and imaginary part. Writing a complex number in this way has an advantage over that other form that we will see. So complex numbers are numbers of the form x plus iy, or just ordered pair xy of real, where x and y are real numbers, with operations of addition and multiplication given respectively by. Complex addition is defined like this: x1 y1 plus x2 y2 equal to x1, it is component wise addition, x1 plus x2 y1 plus y2. If you see that match with that other definition, it is x1 plus iy1 plus x2 plus iy2, then also you have that same thing. Real part becomes x1 plus x2 plus I into y1 plus y2. So it is the only thing that matters.
Sir,
that the real part and imaginary part. So we are.
Sir, you are not
yes,
showing my PPT. Sir, you're sharing your screen. Sir, your screen is not.
Oh, it's not visible.
So you are not presenting?
No, sir.
So you are not presenting, sir?
Okay.
From the very first.
Now?
Yes.
Now are you looking the
No, sir.
No, no, sir. No, sir.
No.
No, sir. It's only showing presentation for the dinner.
Now?
Yes, sir. Yes, sir. यहाँ पे is showing as going down. Visible, sir.
Well,
Yes, sir. Visible. Visible, sir.
so what I was telling that complex numbers we represent like this: z equal to ordered pair xy. Usually we write x plus iy, but that I remains constant. So that means that
So PPT is not visible.
visible.
Visual.
Anyone?
Visual.
It's visible, sir.
Yes, sir. Now visible, sir. Yes, sir.
Anyone see?
Visible now.
So maybe your network.
Visual, sir.
I will share the notes also. Yeah, it will appear due to your network problem. Okay, so that complex number we will be writing either in this form. Where x is the real part, y is the imaginary part, or it means that same thing. You can write equal to this x1 plus x2 y2 equal to x1 x2 comma y1 y2. In multiple addition, no problem. The way we think it is defined like that only. Component wise addition, but in case of multiplication, it is not like this. x1 y1 multiplied by x2 y2. So multiplication also we think that it should be component wise multiplication. It should be to x1 x2 comma y1 y2. Multiplication is defined by this formula. Getting it? So what is the reason? What do you think? Why do you think it is defined like this? Addition, it was fine, but we think first that it should be component-wise addition. In multiplication also we think that it should be x1 x2 comma y1 y2. But instead of that, so it is defined like this, which looks quite complex. Can anyone tell why it is defined like this? What is the if we define complexification also as component-wise multiplication?
Sir, because of the value of I, which is root over -1, so when I multiplies with I, it comes out as -1.
Here you see we have never written I. So that is the thing we wanted to tell you to explain why we are defining complex multiplication like this. I does not matter. I is just a symbol. Isn't it? Root over -1. If you are telling from your knowledge of real analysis that square root of 4 is 2, square root of 9 is 3. So in that way, if you see, then what does square root of -1 mean? Does not mean anything from knowledge. Square root of something negative. How we usually visualize square roots. It means square root is a number. If we take it square, then it gives us back that number. And if square root of 4 is 2, means if we multiply 2 times, we get 4. Now square root of -1. So from our knowledge of real analysis, square root of some number should be
Sir, voice is lagging, sir.
square root should be applied on that. Yeah, due to network, sometimes it might be lagging. So what I'm asking is that is defined like this using I. I came from here only. In the definition, we have not written any I anywhere till now. So why it is defined like this? It is for some reason. The reason is that in real number system satisfies certain properties. that one important property is that every non-zero real number has a multiplicative inverse. Multiplicative inverse means 3 is a non-zero real number. Then there is a number by which if we multiply 3, then we get the unity element. Unity element means 1. So 3 multiplied by 2, 1. It is 1 by 3. So similarly, suppose square root is there. Square root, if there is another real number now, which if we multiply square root of 2, will give us 1. That number is 1 divided by square root of 2. So this way every non-zero real number has an inverse. It is a very important property for any number system, that every non-zero number should have its multiplicative inverse. Otherwise not a number system. So in complex number system also, we want to preserve that property, that every non-zero number should have a multiplicative inverse. If we define complex number as component wise multiple, that this multiplied by this is equal to x1, x2, comma 1, y2, then you will see that every non-zero complex number will not have a multiplicative inverse. This is the only way if we fix multiplication, then only every non-zero complex number has a multiplicative inverse. By that, what we mean, suppose 0, 3, 0 and 3, this number, it means your 0 plus I 3 means 3I. This complex, non-zero complex number, because 0 complex number is 0, 0. This complex and unity of complex number is 1, 0. There is only 1 plus 0I, which is 1. So 0, 3 multiplied by which complex number should give you 1, 0. That we can find out. So this will definitely exist. There will be another non-zero complex number which we multiply 0, 3, and we are getting 1, 0. If we define complex multiplication as component-wise multiplication, then here you get that any number by which if you multiply, suppose 0, 3, then for component-wise multiplication, you should get something non-zero. X into y should be equal to number a multiplied, non-zero number a multiplied by 0 should give you 1, which is never going to be possible. That's why if we define component-wise multiplication, then a non-zero complex number is not going to have a multiplicative inverse. That's why we cannot define this. This is the only way, in fact. There is no other way by which complex multiplication will give you an inverse, multiplicative inverse every time. That's why complex multiplication is like this. And then only I comes, that why we call I equal to square root of minus 1, that can be explained from this definition. You say that because I square root of minus 1 and I square equal to minus 1, then there is not a proper explanation. Notes are there. In equal to x is called the real part, y is called the imaginary part. And two complex numbers are equal if and only if their corresponding real and imaginary parts are equal. Then for any complex number z equal to x, we can write it, we can always write it in this form. Xy can be written as x0, there is one complex number, plus 0, 1 into y0. This way we can write, do the calculation according to this complex addition and complex multiplication, and you see that this will be xy. Now this the operations when restricted to real numbers, we have this. When these operations are considered for real numbers, then we have these two equations. The complex number system is therefore a natural extension of real number system. So if x is a real number, then we can write x as x plus I0 or simply x0. And we denote 0, 1. Now 0, 1, here we have got 0, 1. Every complex number can be written in this form, where always there will be a 0, 1. This 0, 1, this order denoted by I, it is our I. So that I square equal to I into I according to this formula of multiplication, I into means 0, 1 multiplied by 0, 1. Now, according to this formula, gives us minus 1, 0. Means the imaginary part is 0. So that is equal to minus 1. That is the explanation why I square equal to minus 1. Otherwise, you cannot find from your knowledge of real numbers, you cannot explain why I square equal to minus 1, because from our knowledge of real number system, we know that square of every number means real number should be non-negative. Either it is 0 or positive. It cannot be negative. But in case of complex numbers, we have something different. That square of a number, complex number, is giving you a negative value. How this is possible? This is because complex multiplication is defined this way. And the reason such type of definition for complex multiplication is that we want to construct a number, and one important property of number system is that every non-zero number should have its multiplicative inverse. By any other means, if you define complex multiplication, it is not going to have a multiplicative inverse. Every non-zero number is not going to have a multiplicative inverse. That's not be a number system. That's why it is defined like this, and that is the explanation why I square equal to minus 1. Now we can tell why I square equal to minus 1. What telling earlier that I equal to square root of minus 1, you cannot explain it from the knowledge of real number system. It is only because of this definition of complex multiplication. Right? You also have an integration I cannot show you right now, because if you multiply any complex number by I, it gets rotated clockwise direction by 90 degree. So if you see what the position of 0, 1 in